All right, so we'll kick off IPFS, and then we'll kick off our daemon and clear the queue. So this part is like the queue cache. So that clears it, and I'm maintaining an output log, which I'm using for like when we're profiling and stuff. I can like grab for debug statements. All right, let's see. So the sample job is using our AI as input. Okay, so these are like all of the starter children that we start with. So I actually don't remember what formula we used to generate this. But this is like if we give it -9, we get 162 out. So I'm guessing we're squaring something. I don't know. I guess we'll find out because it should figure it out on its own and we don't need to do it. Okay. So we can cat that, or it's, we have to cat that sample job and generate a task out of it. And then we'll send it off to I actually like have a little thing in here that I can use to like benchmark it, so like that'll actually track how long the time takes. All right, so it looks like it's running.
Okay, submitting tasks.
Yep, I did like a little. There we go. This guy, which shows like that there's one. It shows 111 because it's about to generate all of the children tasks. So if we wait a second, it'll pop up. This is like how many tasks are available, how many have been currently assigned to machines, and then how many are completed. So there we go. So these are the five islands. So those are like the parallel like computations that happen. And then it'll run them in series because it's just my laptop. I'm actually like disconnected because Jade was giving me a whole bunch of work to do the other day, and it was bogging down my machine. How's it going? It's just gonna take a while. So like this genetic stuff takes a lot longer to run. If we Docker PS, we can see it running right here. So right, so now we're at like 17 out of 50, and you can see like the children that's generating. It looks like this is it, because like that is like 5 times 10 to the -4, so it's really close. The only reason why it's not, this is like the cost functions, this is how wrong the function is. The only reason why it's not 0 is because Aaron and I made it so that the longer it is, it counts against it, and this isn't a 0 length function, therefore it has some cost, it's just very small. And that was to incentivize the system to produce shorter and shorter functions. But it looks like, so it looks like the answer is 2x squared, right? Because that's prefix notation, but that's x times 2. So theoretically, there is actually a shorter function. It could well, that was one island. It's actually gonna run 5 of those in parallel, and hopefully one of them will figure out that there actually is a shorter function, which would be like star 2xx, right? Like we don't have to have this nested piece right here, but we'll see. So we'll do. And I aliased C to computes just to save a bunch of time. But yeah, so the third island is now available. It has not been grabbed yet. I bet it probably has by now. Nope. I wonder why. Because normally that goes really, really quick. I wonder if there was a problem with it. Well, I don't see any errors in our log. This is it like manipulating its own queue.
That's pretty cool.
But I'm only like logging the data set, so you can't really like, this is like one of the implementation details of the queue. So like it's kind of hard to see what's actually going on because you're looking at the underpinnings, like their higher level functions. There it goes. Looks like it just picks them up. Oh, it actually completed the job, moved on to the next one. Okay. Well, I didn't expect that. Are we having, because it's working on a job right now. Yeah, so there's, I got the queues mixed up. I forgot. This is available. This is in progress. This is completed. I was thinking that this was in progress for some reason, but it's not. It just meant that it's being worked on. So the queue is fine. I was wrong. Yeah, so that's why there was no output here, because it was just working on the job. So
this is probably a lot more fun to watch when you got several machines all.
Oh, for sure, because like all of this could have been done in like a fifth the time, because these are completely done in parallel. Like this job is not dependent in any way on the output of the other jobs. So like if we had like your Raspberry Pis, for example, like we could have just had them all do it.
Pretty cool.
So, and the other, oh, it must have already been completed. The other thing too is if you notice, the number of epochs that happen, it seems really high because it doesn't act. It gets like into a local minimum much quicker. Like, look, this guy's already right. Well, no, that's not true because this guy needs a 2 in order to make that correct. Yeah, look at all the stuff that it's trying. It's so wrong, but it's figuring out. Hey, there goes. See, so like.
Yep, it added the 2.
And like maybe it'll get the right answer, or like get a more correct answer by 50, but like we probably could have stopped at 10. And
Best creature.
Like one of the things we could do is like when this number gets below a certain amount, like early return or something. So we're like, maybe this isn't the guarantee, like this isn't the provably like best answer, but it's good enough.
It, yeah.
Right. Or like if it stays stable for long enough or something, I don't know. Like if there's like 10 in a row where the best creature hasn't changed, just give up. That's the one I wanted. Okay, cool.
5.
So that's all of the islands. So now we should see a 6th job pop up that there you go. That aggregates all the results together. So basically, like looks at all the islands, compares all of their creatures, and picks the best one. Cool. Yeah. And so that's done now. And so now we have that task from way before. Or let's scroll back up. I have so much output. There we go. When we generated that task, this is the dataset object. So that's where all of our results stored. So the computes CLI dataset dump latest. And drop that hash in. We'll get the latest version. I mean, there's a lot of data here, so we're not going to go through it by hand. Because like the input and outputs of all 3 types of jobs are in there. But really the only thing we care about is our reduce.results, which is still going to be pretty big because that actually I think contains all of the creatures from all of the islands that survived, like ordered correctly. But the thing that we do care about is this winner down here.
Oh, nice.
But so that's the idea. But it's all running in here. All of the islands independently derived that as the winner, but that happened because this is such a simple, we call them creatures.
Yeah.
But like when we did like a x cubed polynomial, so like 3x cubed plus 5x squared plus 2x minus 3 or something like that, then like you get into a case where like you actually need all those 50 epochs and like only maybe 1 or 2 islands actually produce something meaningful. And then sometimes even then like you didn't get close enough to the answer. And so what we can actually do is this output that happened, we can like feed that in as the input to the next job, which is kind of fun. So like there's an address for this, and then if we were to like point that input address back into system, we just run the whole thing again. It'll split back into 5 islands and then repeat. And so like we could automate that too, where it like repeatedly runs until it gets to an answer that's good enough.
This is impressive. I want to see this on multiple machines.
Yeah, me too. That's the exciting part. I can spin up on our DigitalOcean instance. I already got a DigitalOcean instance ready to go. I just gotta